Hey, what is good, you guys? Welcome back to yet another video of our channel, and I hope all of you are well. So today's video is going to be about environment and package management using Conda. So without any delay, let's get started. Before moving on to Conda, let's first understand what environment management and package management is. So consider that you have been newly hired as a developer and you're working on Python-based projects. Your current assignment requires you to use Flask 2.0, the Flask with version 2.0.0. So what you do is, you install Python and then you just do a pip install Flask. So and assume that you do a pip install Flask and you give the version 2.0.0. Along with that, you install a few additional dependencies as well. Nothing bad so far. So far so good. Flask is available to you. You configure the interpreter and you build and test the app. Everything is working as expected. You and your bosses are both happy. The bosses or the seniors still don't know that you installed everything in your base Python installation only. Now 2 months later, you have been tasked with building another app, but this time it uses Flask 2.2.1, a newer version of Flask which is available. What you go and do again is you start up your Python, you do a pip install Flask 2.2.1, and then you start building the app. You build the app and then you go and test it. So the app isn't working as expected. Now you start scratching your head, and you think maybe it's worth checking the old app as well if that's working. And no surprises there, that app is also broken. So you have the new code is not working and the old application which was working is also broken. What happened here? What happened is that you installed Flask in your base Python location and you installed a newer version in the same location. So your two different projects which require different versions of Flask now use the same Python interpreter or the same Python installation which have conflicting versions of Flask, and everything is messed up. So this is the problem that virtual environments aim to solve. So what a virtual environments do is, for each and every project, they allow you to separate dependencies. You Ideally, when working with a Python environment, when working with Python or any other language, it is best to have a separate workspace or a separate working environment where you can install packages or dependencies specific to that particular project. The act of managing these virtual environments is called environment management. In summary, virtual environments help you to isolate dependencies of different projects, and the act of managing these virtual environments is called as environment management. In the Python world, there are quite a few options available for environment management. The popular ones are venv, which comes with the standard Python distribution, virtualenv, which is third party, but the venv is actually based on virtualenv itself. Conda, Poetry, Hatch, and pipenv are some other popular environment managers. Some of the environment managers are also package managers. We will now talk about what package management is. So when you start building Python projects, you do pip install. So when you do pip install, a package gets installed from the standard Python PyPy repository in your local system. So the act of installing these packages is called as package management. Package managers provide a variety of functionalities such as installing packages, removing packages, upgrading packages. Pip is the most popular package manager, and it's available with the standard Python distribution. Along with pip, the other environment managers which we talked about are also have this capability of package management as well. For example, Conda, Poetry, all of them are environment and package managers, but pip is only a package manager. That is, you cannot manage virtual environments with it, but with the help of Conda and other third-party applications such as Poetry, you can manage both environments and packages. At the home page of Anaconda, and Anaconda is an organization, it's a company which provides solutions. And Anaconda doesn't only offer package management or dependency management for Python, it offers for other languages such as Ruby, Java, and so on and so forth. You can read more about them on the official web page. Saying the name Anaconda does feel weird for the first couple of times, but it is what it is. Yeah, coming back to the topic, we'll now talk about when you start hearing about Conda, you'll hear two different terms, that one is MiniConda and the other is the Anaconda. So the difference between the two is that MiniConda is your minimum installation, which only gives you package and environment management, whereas Anaconda is a whole set of or a bloated version which comes with standard packages which you need for data science or ML kind of work, which already have installed. So if you see, the Anaconda installer requires almost 594 MB of space, But MiniConda doesn't need that much because it doesn't come with all these packages pre-installed. With the knowledge of what is the difference between MiniConda and Anaconda, we'll now go ahead to install MiniConda on our machine. We'll not be installing Anaconda because we don't need so much. And if you see, I think there'll be somewhere MiniConda. Let's see how much space it actually consumes. So if you see, that was fairly quick. So let us go ahead and install MiniConda. The installation is pretty simple, nothing much. You don't have to do any fancy configuration, just run it, and whatever the standard configurations are, just keep them as it is. I'm going to choose next, I agree, just for me, and install. So this is the standard location, users PC this, and if it requires 278 MB, which is much less. And register MiniConda as default. I'm just going to uncheck this for now, and I don't want to add MiniConda to my default path. Come back after the installation. Right, I think the installation is now complete. Get a tutorial getting started, no, and just let's finish it. So let's see what we get with the distribution. So the two most important things which you get are the Anaconda prompt and the Anaconda PowerShell prompt and the Anaconda prompt as well. Let's start the Anaconda prompt, which is nothing but a command prompt, but just based for Anaconda. And this is what it looks. It's very similar. So let me just what do you say, enlarge this. It's very similar to your command prompt, but it does operations specific to the Conda. Let us see let us see first the Conda version which we have installed, and the command for that is conda -version. So we have Conda 4.12.0 installed. Conda is now ready to be used, and if you see, it is already at the base base installation. Now let us quickly go and check the path where Conda was installed and see what it contains. So this is the installation location of MiniConda, and if you see, it has a lot of files. Our area of interest is this folder called as envs. So this is where all your virtual environments which you create will now reside. Currently it's blank, and we'll soon see how this gets filled up with all the environments which you install. Let us look at channel URLs. Now, if you're familiar with pip, you know that pip installs packages from the standard Python package index, pypy.com or whatever the extension is. But Conda installs packages from the repo.anaconda.com. So these are the locations, or these are the channels. So these are the locations where Conda will look for those packages. It will not look for it will not look on the standard Python package index, but it will look on the Anaconda's own repository. So this practice is pretty common in all organizations as well. None of the organizations, or almost all of the organizations, will not allow you to connect to the standard Python package index, because people are uploading packages to the Python index, the Python package index every day. Not all are 100% secure, and there would be vulnerability concerns. So what most organizations do is take the packages and store it in their own repository, and own repository, or a copy of their copy of the Python package index, and allow us to connect to the local or the internal package index. So what that does is guarantees safety and security of the internal network and the organization. We can be 100%, we can scan all the packages and be 100% sure that this package is not malicious or doesn't contain anything which might be a virus or malware or stuff like that. So this is the standard practice, maintaining internal repos or internal package indexes. Similarly, Anaconda does that as well, and by default it connects to repo.anaconda.com and not pypy. So this is about channels. So channels can be changed as well. You can use alternate channels, and you can add that in something which is called as the conda rc file. So this is the default configuration file. It doesn't get created when you install Conda, but you can create it by firing the conda config command. And conda rc does actually the conda rc. So let's talk about conda rc for a minute. It's a optional configuration file, and it allows you to do settings such as the channel URLs, using of HTTP proxies if you're sitting behind a firewall. So if you want, if your organization does allow to connect to the standard Python package index using proxies, you can do that in the conda rc file as well. The configuration of conda rc file is not something which is in the scope of this video. So if that is something which you want, you can request that in the comments as well. Let us look at channel URLs. Now, if you're familiar with pip, you know that pip installs packages from the standard Python package index, pypy.com or whatever the extension is. But Conda installs packages from the repo.anaconda.com. So these are the locations, or these are the channels. So these are the locations where Conda will look for those packages. It will not look on the standard Python package index, but it will look on the Anaconda's own repository. So this practice is pretty common in all organizations as well. None of the organizations, or almost all of the organizations, will not allow you to connect to the standard Python package index, because people are uploading packages to the Python index, the Python package index every day. Not all are 100% secure, and there would be vulnerability concerns. So what most organizations do is take the packages and store it in their own repository, and own repository, or a copy of their copy of the Python package index, and allow us to connect to the local or the internal package index. So what that does is guarantees safety and security of the internal network and the organization. We can be 100%, we can scan all the packages and make 100 be 100% sure that this package is not malicious or doesn't contain anything which might be a virus or malware or stuff like that. Similarly, Anaconda does that as well, and by default it connects to repo.anaconda.com and not PyPy. So this is about channels. So channels can be changed as well. You can use alternate channels, and you can add that in something which is called as the conda rc file. So this is the default configuration file. It doesn't get created when you install Conda, but you can create it by firing the conda config command. So let's talk about conda rc for a minute. It's a optional configuration file, and it allows you to do settings such as the channel URLs, using of HTTP proxies if you're sitting behind a firewall. So if you want, if your organization does allow to connect to the standard Python package index using proxies, you can do that in the conda rc file as well. The configuration of conda rc file is not something which is in the scope of this video. So if that is something which you want, you can request that in the comments as well. So having talked about the basic installation, what the info command does, what the version command does, and what channels are, let us now move to creating a first environment. And there are a few options which you can use to create environment. Now there's a handy cheat sheet available on the Conda website as well, so you can download that, and all the commands will be available here. I'll leave a link to this in the video description as well. So let us create our first environment, and what there, as I mentioned, there are a few options, and the first one is conda create command, and hyphen name, or you can use the shorthand n, and our first env, and let us allow the environment to be created. So you see, it points to the location where the environment will be created, and this is exactly the same location which I showed you, that it was blank, but let us now press yes and see what happens. So if you see, conda environment is created, and it tells this command to activate and deactivate the environments. But before that, let's go and look at the env folder. So if you see, the env's folder already contains our first environment, and currently it does not have anything, or no packages are installed. As I mentioned, one of the advantages of conda is creating packages using different versions of Python, and you can do exactly that using create-m python 3.7 env, and just give python is equal to 3.7, and let us see what this does. If you see, it is asking us to if you see, we gave the Python version 3.7, and it says that it needs additional installations. So let's do that. Right, so a Python 3.7 environment is also ready. Other ways to create environments as well, and one of them is using a YAML file. Now, when working within a larger organization, there is always a need to share your environment files across teams, so that you use the same set of dependencies, and Conda allows you to do that as well. You can create a YAML file from your environment and share the YAML file with other developers who can create their environments using that YAML file. So to do that, we have to first activate the environment. So to activate an environment, the command is conda activate python 3.7 env. I think this is what we named it. Yep, so the environment is activated, and now what you can do is conda env export, and give it the name shared python 3.7.yaml, and if you give it like maybe 30 seconds, the environment will be created. And if I do a shared python 3.7 start, yeah, the shared python 3.7.yaml is already created. The other developers can import this YAML file and create the environment using the command conda env create -f and shared python 3.7.yaml. So this is how it works, and the command for that is conda create --name my clone, and so my clone is the name of your cloned or the new environment, and -clone is the name of the existing environment. So if I just do shared python, maybe not shared python, but python 3.7 env. So what this command will do is it will create a new environment called as my clone, and it will be cloned from 3.7. So let's just try this out as well. If you see, and the source is 3.7 and the destination is my clone, it is already created. So now Conda deactivate and Conda activate my clone. So if you see, my clone is already activated, and if I do a Conda list, I know some of these commands such as Conda list are getting a little bit ahead of ourselves, but if you see, the same set of packages are still available. And if I just do this as well, these are the same packages which exist in our cloned environment as well. Again, let's take a quick peek at the envs folder. If you see, all the three environments are now present. So this is where all our envs reside. Now this is the default location, and again there's a possibility to override. If you don't want them to be in the envs folder, you can do that. You can just override this path as well. But that is another advantage which Conda gives over vn, which is the default environment manager, that the installations, the virtual environments are created in the standard location, and then when you want to commit your source code, then you don't need to kind of get ignore the environment files, because if you use vnv, the default location is the same directory as where you're working, and you will always need to get ignore the environment. The other set of basic commands which you'll need is to deactivate the Conda environment. So the command is pretty simple: Conda deactivate. So it will deactivate whichever your environment is. Also list all the available environments using Conda list envs. Conda list envs. Sadly, we don't have any, so I think this command is wrong. So Conda env list. I think that is the correct command. Yeah, if you see, we have the base environment and the three which we created. The other option to list all the environment is Conda info --envs. So these are the two methods which you can use to kind of list all the environments which you have. The installation of packages is very simple. Firstly, let us activate one of the environments. So maybe Conda activate our first env, and our first env is activated. So it's essential that you activate the environment first, or you again corrupt the base Conda installation. And if we do a python version, it is 3.11 which is available. So let us maybe create an environment which doesn't use 3.11 because it's still it's pretty new. So we Conda deactivate and Conda create hyphen name. Maybe actually we do have the Python 3.7. Why do we need to create Conda activate Python 3.7 env? This works just fine. And so let us try to install a few packages. The installation is pretty simple: Conda install Flask, and it then Python package index, it fetches from the repo.anaconda. And if I now do a Conda list, we have much more packages. Again, to list all the packages, it's pretty simple. The command to list all the installed packages is pretty simple to pip. Instead of pip list, you can use Conda list. If you want to install packages with a specific version, the command is again pretty same: Conda install, say give me package name, fast API is equal to fast API equal to 0.78 maybe. So it's not able to find this, but I think I know why. It's 0.7.0 0.78.0. so yeah. So if you see, what the error says is that it could not find any packages with the name fast API is equal to 0.78. This brings us to a nice command which you can do, is search packages which are available on the report@anaconda.com, and the command to do that is Conda search fast API, and it does expression matching as well. So if I do Conda search fast API, what it will basically do is it will go to repo.anaconda.com and search for all the packages. So if it's not able to find any fast API, which is a bit strange, so I'm just going to do fast API. Oh, it's still strange. Let's try to find Conda search Flask, not Conda but Conda search Flask. Hopefully it's able to, yeah, it's able to find Flask. So essentially what happened is, I don't think report.anaconda has fast API. It's a bit strange, but yeah, it is what it is. Conda search maybe numpy, 100% they'll have this because they are more into data science and all kind of. If you see, the Conda search command lists all the packages which are all the versions of the numpy which they have available. And if I just try to install maybe numpy is equal to 1.23.1 I wanted to type 1.23.1 3.1, so this is correct this time. So let's correct the version number this time and try to install it. So what this is essential complaining is the compatibility. So Python 3.7 and NumPy 1.2.3 are not compatible. So let's try to install maybe 1.17.0 and let's see if it allows us to do that. Now it's okay then. The installation is done, and now if I do a conda list, NumPy should be present somewhere, maybe here. And coming to the last command on the installation part is obviously the uninstall, and the uninstall is also pretty simple. Conda uninstall, not uninstall but uninstall, and NumPy current environment. You can also specify the version as well, and if I just do the y, it will uninstall it. So the uninstall is done, and now if I list it, let's see if we're able to find. So if you see, the list is already shorter, and the NumPy is gone. So that is about installing and uninstalling packages using Conda. The point worth remembering here is that it installs from the it does not install from the Python package index, but it goes and searches the repo.anaconda.com, which is Anaconda's internal or Anaconda's own version or maintained version of the Python package index. We have seen how to create environments, how to list environments, how to activate, deactivate environments, how to install and uninstall packages. All that now remains is how to delete or remove an environment, and the command for that is very simple. So let me just quickly deactivate the environment, and conda env remove -name, and the name of the environment is Python 3.7 env. So this is the environment which I'm going to remove. So if you see, remove all packages from the environment, and if I now do a conda info or conda list envs, not conda but maybe conda info envs, if you see the Python 3.7 installation, the Python 3.7 environment is already gone. And you don't have to remember all these commands. There's a nice cheat sheet available, and I'll leave a link to this in the description as well, and you can use it for all your references. That is all about environment and package management using Conda. Again, just to reiterate that this is just one of the options available, and I currently use this and it suits me very well. So if there are other options which you can explore, and in the comment section you can leave your feedback about which one do you prefer and what are the advantages of one over the other. There are obvious pros and cons of each other, but yeah, what I did my best to explain Conda and why I use it, and it's my preferred environment and package management. So before I leave, a humble request to subscribe to the channel if you haven't already done so. For the algorithm, do like and share the video as well. And also leave your valuable feedback in the comment section. It will help me keep motivated if I'm relatively new to content creation. And so if any of the content is kind of missing or it lacks something, do leave that in the comment section, and I'll definitely try to improve on the same. So thank you for watching.